Good afternoon, everyone. Thank you so much for joining us today to learn more about grasshoppers. My name is Jennifer Thompson. I'm the Small Acreage Outreach Coordinator with the University of Wyoming Cooperative Extension Service. I serve the Small Acreage Outreach Project, and you can see all the different organizations that it consists of in front of you. We do many things, including supporting workshops across the state and producing the Barnyards and Backyards magazine. You can see many of those items by visiting barnyards&backyards.com. But today we're lucky to have Scott Schell, University of Wyoming Cooperative Extension Assistant Extension Entomologist, with us to talk about grasshoppers. It should be a very interesting presentation. Scott.
This is Scott Schell, and I'm the Assistant Extension Entomologist, and I'm here to talk about grasshopper management strategies today with a presentation that I developed with my boss, Dr. Alexander Lakshinsky. And hopefully you'll learn something of use to you from the presentation. As usual, no product endorsement is implied from any kind of brand names that are used. Just a little bit about grasshoppers to begin with. You know, we generally kind of think of insects as being kind of insignificant little critters, but grasshoppers, despite being small in size, can cause a lot of problems. And one of the things about them is their appetite. A lot of grasshoppers can eat their body weight daily in vegetation, and a two-striped grasshopper, which is a common pest species in croplands, in suburban situations, and gardens in Wyoming, the way it eats can weigh 6 times more than it eats, and it's been found in certain situations in crops that it only takes 10 adult two-striped grasshoppers per square yard to defoliate a corn crop. So despite their small size, only being about 1.1 gram as an adult for the large two-striped females, that works out to about, at a low density of only 30 per square yard, that's about 200 pounds of grasshoppers per acre if you scrape them all into a pile. Now, of course, a lot of the range species are smaller, like this clear-winged female down here, only being about an inch long and a little bit smaller. But certainly their numbers can be much higher than that and cause a lot of problems. On rangeland, it's thought that on average in the northern mixed grass prairie that about 14 per square yard density is equivalent to a 30% forage loss over the course of the growing season. So certainly some years, if you're having droughty conditions and you're not producing much forage, it can be more damaging, or in wet years, conversely, you can tolerate more grasshopper damage. Now, the grasshoppers, for the most part, they all have a similar life cycle. Now, the major pest species that we have in Wyoming, they hatch in the spring. Usually they can start hatching anywhere from May 15th all the way into early July is when we see a lot of the rangeland species hatch and cause damage. When they hatch out of the ground, they look like a miniature adult grasshopper, only they lack wings, and go through incomplete metamorphosis. So they have to molt in between each growth stage, and they get bigger each time, and their wing pads become more apparent. This helps you determine what instar they're in, or stage. And usually this occurs over a period of 26 to 40 days, depending on the species and the temperature that's going on. This molting is critical. It's not really, something that most people notice. A lot of times at meetings I ask people, have any of you seen grasshoppers molting? And very few people have, even though they do it 5 times throughout their life cycle. They're secretive about it, and certainly they're very vulnerable at that point. And it's also important to know this because one of the best products that we have to use against grasshoppers interferes with this molting process. The grasshoppers, after they become adults, some of the species are good flyers and can move around if they've exhausted the food supply in their area. If they haven't, they'll usually stay in that area and will mate and then lay eggs. Females essentially will lay eggs in pods, and this will protect them through the summer months if they lay them early in the spring, and then through the fall and winter, and can then actually protect them through very terrible conditions of extreme cold, and in some cases a lot of moisture. So usually the adult pest grasshoppers only have a lifespan above the ground of about 3 months. Again, I said they go through simple metamorphosis. This is an example with that clearwing grasshopper again, which can be a pest in mountain meadows, irrigated grass hayfields, and pastures. Usually in the western part of the state, in more areas that are higher in elevation. It's not a big problem in the eastern part of the state, but it certainly it can be a big problem in those areas where it's present. Now, most grasshoppers live and die in the vicinity of where they hatch. What happens is people don't notice them when they first hatch. Now, this little blurry picture here, this is a first instar grasshopper perched on the edge of a Canadian dime, just to give you an idea how small some of these species are when they first hatch out. So they're about the size of a grain of rice. And some species, nymphs, after they get older and more mobile, and if they've exhausted all the food in an area, they can and will march several miles to find food. But like I say, most of the time in the early part of their life, they're in the vicinity of where they hatch. Now, other grasshopper species like this migratory grasshopper, this is an example of one that certainly has good long wings and is capable of flight. And this has been the majority of the pest species that have been plaguing us for the past 2 years. They had documented flights out of the Dakotas during the Dust Bowl years of up to 100 to 200 miles into eastern Wyoming, and so that is problematic for you because if you're a rancher or a farmer and you can be taking care of your grasshoppers on your place and then have a swarm of these grasshoppers land on it later in the summer and cause you a lot of damage. Now, what I tell people is essentially you can't really manage something that far out of your control, so you better take care of your grasshoppers that you have on your place, and then just hope for the best that you don't get this on you, because it's a fairly rare occurrence in most situations that this happens, but it has happened in the past. You know, most grasshoppers in North America have one generation per year. We're lucky there. Some of the species in subtropical areas or some of the locust species that plague Africa and Central Asia and the Middle East have multiple generations per year, but we only have, for the most part, one generation per year. The eggs are laid mostly in the soil. There's some of them that will lay them in the crowns of plants. Some of them prefer bare soil. It's kind of species dependent. The females can lay 1 to 4 egg pods per season during their life, and we think that's probably critical to when outbreaks occur. In the years that they can produce more egg pods, well, of course you're going to have more eggs for next year, and even if you have bad conditions, the survival won't be that, you'll still have enough survive to cause you problems. Most of our rangeland grasshoppers have from 5 to 40 eggs per egg pod. Crop and garden pest species can have 50 to 100 eggs per pod. This is an example of that two-striped grasshopper again. This is what an adult female looks like, and then this is an egg pod from a two-stripe. It's in the process of taking it apart and took this picture. Gives you an example, an idea of the size, and I think there was, if memory serves me correctly, about 86 eggs in this one pod alone. Now, a frequent question that I have is, why do outbreaks of grasshoppers happen? Well, it's part of a natural cycle. Well, if it's a cycle, we haven't quite figured it out. Certainly there are species that are capable of going from normal low population densities, what we think are normal low population densities, say of 3 per square yard to over 30 in one season. So Dr. Fott was an entomologist here at the University of Wyoming for a very long time, and he was a great expert on grasshoppers and locusts, and he once told me that probably every year enough grasshopper eggs go into the soil at the end of the summer that if they all survived and through the next spring and hatched, that you'd have an infestation or outbreak. Sunspots have been mentioned often, and I suppose if you could really tie the activity of sunspots to the weather of the earth, that would be important, because certain weather or abiotic factors play a big role in how successful grasshoppers are. Late summer, early fall weather. Some people have hypothesized this might be important, because grasshopper eggs, they actually have to undergo some embryonic development in order to get to the stage they can successfully overwinter. And so if you have an early, hard, cold fall where you have hard frost and you get that cold temperatures early, the eggs will stop their development and may not make it to the point where they can overwinter. Multiple egg pod production, that's probably a key there, just having more eggs in the ground. Winter weather. Once the winter sets in, if they've reached the point where they can successfully handle the sub-freezing temperatures, it probably doesn't matter to them, even in a winter like this where we had some severe cold. In Laramie, I think our coldest day this winter was probably, I think, negative 38 degrees Fahrenheit. Certainly extremely cold, but you got to remember the grasshopper eggs are in that upper layer of the soil, and even just a little bit of snow cover and the soil helps moderate that temperature, so they probably weren't exposed to that extreme cold. Hatching weather, that's probably a big thing on the grasshopper populations. If they hatch into extremely unfavorable weather, such as extended cold, wet, and rainy like we've been having this spring, that can cause a lot of mortality to the young grasshoppers. They don't have a lot of food reserves coming out of the egg, and then also they're physically small, and a hard rain can push them off of the vegetation, and they'll get caught in the surface tension of water puddles and things like that and actually drown. One theory is eggs from previous years will hatch. Now, there are some insects like floodwater mosquitoes where their eggs are viable for multiple years. And so when you get these wet years and you get more standing water, you could have a huge population of floodwater mosquitoes. Except for some alpine species that actually might take more than 1 year to get to the point where they can hatch, we don't know of many pest species that take multiple years to hatch. I think their eggs are, for the most part, viable for only 1 year. Crop pests, grasshopper reproduction. Now, this is part of the problem with these particular species that are big pests in croplands, is their high rates of reproduction. The differential grasshopper is another one whose egg pods average have been found to be anywhere from 45 to 194 eggs in the literature, and probably average close to 100. So at a density of just 40 grasshoppers per square yard, if you had 20 females out of that 40, and each female only laid an average of 1 egg pod, you could potentially have 900 eggs per square yard. So in those areas around crop fields that are untilled, the egg density can be extremely high. These are pictures of the adult grasshoppers that are in the major pest category for crops. The migratory is one that is very versatile. It can be on rangeland where it prefers to eat forbs first, but will eat grasses, and then it can move readily in the crops. It really likes alfalfa and other legumes. The two-striped is probably our most common pest in crops in Wyoming, although in some areas like in the Bighorn Basin, in the Fly River Valley over around Torrington and Wheatland areas, you can run into differential grasshoppers. This is really when we should be looking for them, and what we should try to recognize on these crop pest grasshoppers is what they look like as nymphs, because that's the best time to do anything about them. The migratory grasshopper and differential and two-stripe and red-legged, they all have what I call the Nike swoosh. I'm probably violating a trademark here, but they have this black and white bar. It's really prominent on the red-legged grasshopper, and this black barring on the femur. And they have an extended hatching period, which is problematic too, in that you can't just treat them once and be done. We don't have any products that last the entire hatching period with a residual that will take care of them. So these grasshoppers, this is part of the reason why we probably saw some problems that occurred later in the season in those crop production areas, like in the Bighorn Basin or around Laramie County, because of this extended hatching. Clearwing grasshopper, just an example, because we have over 100 species of grasshoppers in Wyoming, there's a lot of differences between their life cycles. This is one where they have synchronous hatching, and they as adults, the females will concentrate their egg-laying areas together, and so they have a way of overwhelming their predators by concentrating their eggs in one area, and then when conditions are right and they've accumulated enough degree days, because of soil temperature, it's key on when the eggs will hatch in the spring. So a cool spring where the soil temperatures have stayed low, you delay the hatching. You will see this with these, where they'll come out almost within 24 hours of each other in an egg bed. Now, at an elevation, say 1,000 feet higher, and not very far a distance away, because of cooler soil temperatures, it might take longer for that to occur. But when they do hatch very close together. Another question that I get is, I sprayed for grasshoppers last spring on my rangeland, but my yard and around my water tank still had a multitude of hoppers. Well, there are species differences between a lot of our rangeland pests and those ones. Usually the ones around our farmyards and houses and things like that are the same as the crop pest grasshoppers. They're kind of adapted to the kind of conditions that we create when we are doing cropping or have disturbed land around our homestead and things like that. So the grasshoppers with the extended hatching period could be the culprit, and also pilots, they can't spray over houses or water sources due to liability concerns and having to follow the label of the most grasshopper products. And what are grasshopper sources for, say, cropland? On rangeland, if you have the migratory grasshopper out here, as things dry up and they eat it down, if there's high densities of them, they can move into crops. In most cases, or most frequently I would say, the grasshoppers that are pests in our crop situations will originate, say, like in the corners around irrigated circles, the fence rows, borrowed ditches. Some of the non-crop areas will provide a lot of grasshoppers to move into our fields later in the summer. So another question I get is, my cropland was suddenly loaded with hoppers in midsummer. Why is that? Well, grasshoppers will migrate either as nymphs, they have to walk then, or can fly, and the extended hatch species are capable of this migration. And so you might not have noticed any grasshoppers early in your crop fields, but they were probably hatching close by in those non-crop areas. Because they prefer to lay their eggs in the untilled field borders, in certain situations where people are going to like no-till and minimum till, they're actually seeing grasshoppers that are starting to adapt to those conditions and lay their eggs out in the crop fields. Certain tillage implements like sweeps can allow grasshoppers to survive in cropland even if there is tillage occurring. What we're trying to recommend for folks is to protect the crops before the grasshoppers get into it by treating the source habitats early and often. Because if you're tilling your field, you're probably killing the grasshopper eggs pretty effectively with most tillage methods. But these areas that are not tilled certainly can provide a lot of grasshoppers to be a problem for you. So the way I try to put this in perspective is, say I had a 40-acre cornfield and it just has a 15-foot border around it for the fence row and access path and things like that, and then be able to turn around your equipment. So actually I have 38.2 acres of corn and 1.8 acres of grasshopper habitat. If I just get 200 grasshopper eggs per square yard in that border, and they all hatch and survive and spread over that field, that's the equivalent of 9.5 grasshoppers per square yard. And remember earlier when I talked about grasshoppers at 10 per square yard with the two-striped as adults, they can defoliate a corn crop. So certainly it doesn't take all that heavy a density to get them done. Now this slide's really busy and it's fine print, but I put it up here just because some of it is the wording off of the label for the product that I would use to protect my field. I would try to treat that 1.8 acres of grasshopper habitat around my field sometime in late May, and then I would scatter it again and probably spray again if nymphs are present, because like say we have an extended hatch period. This year you might be able to go early June, early July, and perhaps have to do it a third time in August. But in a normal year, in many of our crop growing regions, I would say late May to get that initial early hatch and have residual product out there for the grasshoppers to hatch into, and then scout and do it again. You can utilize a product called Dimlin 2L at the label maximum rate for just treating on that 1.8 acres and not treating in the crop, and use a volume of spray and an adjuvant to match your spray equipment in the plant cover. Dimlin 2L is a restricted use pesticide, and you have to follow the label to the letter on any pesticide. So for non-crop area, which your fence rows would be, you'd see the grassland section for restrictions. And so what it allows you to do is a total of 2 fluid ounces of the product per acre per cutting. Now, cutting doesn't apply to a non-crop land, and you're not allowed to exceed 2 fluid ounces per year, or 6 fluid ounces per acre per year. So you can do 3 treatments of 2 ounces. And so that will give you the longest residual over that period where you might have these crop pest grasshoppers hatching. So that's what I would try to do if I had my own cornfield. More on the insecticides and what would be the property of an ideal insecticide against grasshoppers, and how do the products that we have currently labeled stack up. Well, this product that I just talked about was Dimlin 2L. Its active ingredient. Okay, Jenny said there's a question on restricted use pesticides and what it takes to apply that. If you're going to apply a product that is restricted use, you have to have an applicator's license. You can get those through taking a training course and taking a test. If there's different levels of applicator's license, if you're going to do it commercially, apply it essentially for other people for pay, you have to have a commercial applicator's license. If you're a farmer or a rancher or a homeowner and you want to be able to apply this product, you have to get an appropriate license for it. And it's an educational program that helps ensure the proper use of the insecticide. And essentially, even though Dimlin 2L is a restricted use pesticide, doesn't mean that it is that much more dangerous than other non-restricted use pesticides. You always have to follow the labeling. It just requires this as an extra safety measure because of its the nature of the product, and essentially because a lot of it is directed to commercial agriculture. And so they feel that the EPA feels that having restricted use is just a way of helping protect the environment and protect the health of people. So back to diflubenzuron. It's kind of a unique chemical in that it affects the insect growth. It affects chitin synthesis, and chitin is the biochemical that provides the strength and rigidity to the insect exoskeleton. And so in order to molt, they have to shed their old exoskeleton and then grow and expand their new exoskeleton. Well, this interferes with chitin that goes into that new exoskeleton that they've consumed enough diflubenzuron. It has some very good pros for it in that it is safe. People and mammals and birds and reptiles and fish do not have chitin. We don't utilize it for anything in our bodies, and so this product has very low toxicity to those organisms. Other insects, such as bees or wasps or insects that have piercing sucking mouth parts that take food from the plant cells and things like that, will not be affected by dimlin because it has hardly any contact activity. It is only through ingestion. And so the way it's applied is on the leaf surface. And so grasshoppers, because they're big gluttons, they can eat a lot of it. They can put it out at very low rates. And so they'll consume enough so that their next molt, it will interfere with their molting process and kill them. It has a very long residual. Extended hatch, occurs over a long period of time. And with dimlin at the 2-ounce rates, you're probably going to have over a month of residual. It is suited for rats. That's that acronym RAATS. This is the treatment system that was developed for use on rangeland in Wyoming. And what this allows us to do is take advantage of grasshoppers' behavior and movement. So on a rat's treatment on rangeland is usually done by aircraft, and so they treat one strip and then they skip the next swath and then treat another. And so it allows for the grasshoppers to move from that untreated area into the treated area and pick up a lethal dose. And so that has savings from the standpoint of application and chemical costs. It also reduces the hazard to the environment by reducing the amount of insecticide that's put out there, and those are good things. It also has less impact on your non-target insects, and such as the predators of grasshoppers and the other things, the pollinators. So these are good things to have. Dimlin has a very good safety record with honeybees. Because of the way it's applied and it's on the vegetation, it doesn't get into the pollen or nectar, and is not carried back to the brood. They've done actual tests with applications over beehives in orchards where this chemical is also labeled, and have found that it does not contaminate the brood and is very effective. Now, I had a question the other day about dimlin and leafcutter bees for pollination on alfalfa. The leafcutter bees are a little bit different in that, unlike honeybees, they will cut pieces of vegetation and take it back to their brood. Now, they make these little nest chambers, and they stock the nest chamber with pollen, and they put their larvae on it. So the pollen should be safe with very little dimlin. Now, if the dimlin has been sprayed on the surface of the leaf where the leafcutter bee constructs that little chamber out of, we don't know. At this point in time, I don't think there's been any studies, at least I haven't found any, that know whether this would be a hazard to the larva of the leafcutter bee. So at this point in time, you would have to play it safe and say, well, if my leafcutter bees might be negatively affected, I might have to rule out dimlin. Although, as an alternative, other insecticides would also be hazardous and probably more hazardous than dimlin. Timing, you got to apply it when they're immatures, when they're nymphs, and certainly that is the best time to apply any product for grasshoppers, is when they're nymphs. They're easier to kill, it takes less to kill them, and they haven't done a lot of damage yet. With dimlin, you can have a sticker shock. It seems like it costs a lot to buy that jug, but remember, you're looking at rates of, say, 1 ounce per acre on rangeland, even down to 3/4 of an ounce per acre. Treated, we've found good results. For non-crop areas, or to protect cropland, I would suggest going with the label maximum rate of 2 ounces per acre. So those are some of the good things and bad things about dimlin. Here it shows this. On the left is a picture of a grasshopper undergoing a normal molt. They usually hang upside down on the vegetation, and they utilize gravity to help them get out of the old exoskeleton. The one on the right was exposed to dimlin as a nymph, and then when tried to molt, he essentially was unsuccessful. This is the new exoskeleton in the eye of the grasshopper. This is his old exoskeleton he's trying to pull out of. And so it's essentially on the right that shows the grasshopper's fate. Oh, they can't see. Oh, I'm sorry. I guess I thought you could see my cursor. My laser pointer doesn't work either here. So